So hi everyone, this is Jay, your instructor for microprocessor and interfacing. Today we are going to see the working of the microprocessor 8085. So let's start. As you can see on the screen, there is a chip. On that you can see there is one microprocessor and there is a memory. So when you program the microprocessor, all the instructions will be stored onto that memory, and processor will start reading those instructions from the memory. So initially the processor will read the first instruction from the memory that you can see. After that the processor will decode that instruction, and after the decoding of the instruction is done, the processor will execute that instruction. After the fetch, decode and execute of one instruction is done, the processor will fetch the next instruction. So it will fetch the next instruction from the memory, that is instruction 2, then after it will decode that instruction and it will execute that instruction. So if you are storing, let's say, 100 of instruction, the process will be same. It will start fetching the instruction from the first memory location. It will fetch, decode and execute. First instruction of the fetch, decode and execution of first instruction is done, then after it will fetch, decode and execute the next instruction, and the process will keep going. But this is a very basic thing. We are going to see what are the steps that are done by the microprocessor when it do a particular process, let's say instruction fetch. What are the steps are done when the microprocessor is doing instruction decoding, and what are the steps are there which are performed by the microprocessor when it is doing the execution. So as you can see on the screen, there is one microprocessor which is connected to the memory. Now processor itself contains so many blocks. You can see that the first block, which is a ALU. What is the function of ALU? It performs different arithmetic and logical operations, right? The next block, it is a instruction decoder. It decodes the instruction. So the microprocessor 8085, it is having different general purpose registers which are B, C, D, E, H, L. These registers are of 8-bit, but if you want to store 16-bit of data, that is also possible. To store 16-bit of data, you can group this register. You can make pair of B and C, or D and E, or H and L. There are some special purpose registers which are called stack pointer and program counter, and the size of these registers is 16-bit. Then you can see the control unit. Now the control unit is connected to all the sections within a microprocessor. You can see that it is connected to ALU, it is connected to register section, so and so. But the control unit is not only connected to its internal section of the microprocessor, it also connects to the outside of microprocessor. You can see that the control unit is connected to memory too. Two different control signals are connected to memory, which is the memory read or memory write. After that, you can see that there is a data bus and the address bus is there in the microprocessor. For the 8085, the length of the data bus is 8-bit and the length of the address bus is 16-bit. Now what is the function of the data bus? Using the data bus, you can transfer data from the memory to the microprocessor, and using the address bus, the function of the address bus to send the address. Right now, using the address bus, the microprocessor will send the address of the memory location. Now let's see how you can program the microprocessor. You can easily program the microprocessor using your computer, but you need the assembler. Let's say I need to provide one instruction to the microprocessor, which is MOV C, B. When you give this instruction to the assembler in your laptop, the assembler will convert that instruction into the machine language and it will store the instruction in the memory. You can see that the first instruction and the only instruction is stored in the memory, and it is in which form? Binary form, which is also known as machine language, and it's a native language of the microprocessor. Now the microprocessor is programmed. Now the processor will start doing its process. So it will first fetch the instruction. To fetch the instruction, it is going to follow some steps. So initially you can see that the value of the program counter is 0. The processor will put the value of the program counter in the address bus. You can see the address bus is having 0000H. So the processor has sent the 0000H address to the memory. Now when this address is received by the memory, that particular location will be selected in the memory. So you can see that the first location, which is 0000H, is selected in the memory. Now the processor has to read that memory location. To read the memory location, the processor will generate the control signal, which is the memory read. And when processor send the memory read control signal, the instruction from the memory will be transferred from the memory location to the microprocessor. And this process is known as instruction fetch. You can see that the instruction is arrived from the memory to the instruction decoder block, and this process is known as instruction fetch. After the instruction fetch process is done, what is the next process, which is the instruction decode. As the instruction is arrived in the instruction decoder, the processor will decode that instruction. You can see that the processor has decoded that instruction, and it is known as the instruction decode. This process is known as instruction decode. After the instruction is decoded, the processor will transfer that instruction from the instruction decoder block to the control unit. So you can see that the decoded instruction is transferred to the control unit, and after that processor will generate different control signal for the execution of that instruction. So processor will send control signal. After the control signal is sent, the data from the register B will be moved to the register C, so that the execution of the instruction is done, and this process is known as the instruction execution. So these are the steps which are done by the microprocessor when it perform instruction fetch, decode, and the execute. And I guess this is the end of this session, and thank you so much.